In this video, we'll look at applications of linear equations that involve percents. Right, so we have two different kinds of percent problems here. One is more of a direct translation problem, and one is kind of a situational question. So let's begin with number one. What number is 45% of 80? So this is the type of problem that you can almost directly translate from words to an equation. So I have the equation written out. What number is 45% of 80? So whatever the missing quantity is, you're going to choose a variable to represent that. So what number is our variable? We can call it x or n or whatever letter you like. Whenever you see the word is, you can translate that into an equal sign. When we're working with percentages, we often turn them into decimals so that they're easier to make computations with. So 45% is 0.45 as a decimal. You can get that by taking your decimal point in the percent and moving it 2 places to the left. You could also divide the percent number by 100. The word of translates to multiplication, so we're going to multiply by 80. I'm going to use parentheses to show multiplication. I don't want to use the X symbol because it might look like my variable, and sometimes when you're writing by hand, using the dot might look like a decimal point. So my equation, just to write it out a little more neatly, x equals 0.45 times 80. So depending on your equation, your variable might be in a different spot, so you'll just go through whatever steps are necessary to find that variable. In this case, my variable is already isolated, so all I need to do is multiply 0.45 times 80, and that gives me 36. So x equals 36. And again, if I wanted to check that value, well, in this case, I don't really have much to check because it's just a matter of multiplying, so just make sure that I multiply that correctly. In the next example, we have more of a situation. It says you have a gift card to a store for $50 and a coupon for 20% off your purchase. What is the maximum value of merchandise, excuse that typo there, of that merchandise before tax that you can buy without going over the amount on the gift card? So we want to know how much can we spend so that we don't have to, pay any of our own money except for the tax. So we're kind of ignoring the tax in this situation. So we want to spend $50, but we want that $50 to be the total after the 20% is taken off. So we know that we could spend a little more than $50, but the question is how much more than $50 can we spend? So in order to figure this out, we need to kind of set some variables. So let's go ahead and do that. So on my paper here, I just kind of wrote down the important information. We have a $50 gift card. We have a 20% coupon. So let's let our variable x be the value of the merchandise, just abbreviate merchandise, before the discount. So before we take off the 20%, we want to know how much we can purchase. So now when we're taking a discount, we want to find 20% of that value, and then we want to subtract it from the original amount. We could think about x as also the original amount of the merchandise that we're buying. So we can write that as an expression, the original amount of the merchandise, x, minus 20% of that original amount. Well, we can translate that into an expression, much like we did in the last example. So 20% we will rewrite as a decimal, x minus 0.2 or 0.20 of means multiply times x. So this represents the sale price of the merchandise. And this is before tax. So I want that sale price to be equal to $50 because that's the amount I want to spend. So x minus 0.20x equals 50. And then I could go ahead and solve this equation. So I do have two like terms that can be combined on the left-hand side. Think about the coefficient 1 here, 1x minus 0.20x. 1 minus 0.2 would be 0.8 or 0.80. You could also think about this as if you're taking 20% off the total, you're paying 80% of the cost, which is really what this expression means. So I want 80% of the total merchandise to be equal to $50. And in order to solve this equation, I'm dividing by 0.8 on both sides. And when I divide, I'll write this over to the side, I have x equals $62.50. So that means that if I got merchandise that totaled $62.50, then applied a 20% discount, that total would now be $50. So I could use my $50 gift card, pay for the amount of that merchandise, and just be responsible for the tax if my merchandise was taxable.